So I told you guys that law of sines is not something you're going to need to worry being like tested on or anything like that. I'm not going to, it's not going to show up on the benchmark or anything, but I still want to present it to you just because it is kind of pertinent. Okay, and then we'll also introduce the law of cosines today too, but we won't. We'll continue the law of cosines tomorrow. Okay. Okay. All right. So the ambiguous case for the law of sines. Okay. The first thing I want to make clear here is that this only occurs for side angle triangles. Oops, and this pen is just about to die here. Okay. Only occurs for side angle triangles. Because that is not a triangle congruence, right? Side angle, not a triangle congruence. In fact, your book normally highlights the fact that it's not a congruence, right? Okay. So the other situations where we did law of sines, we had angle side angle. Okay. Angle side angle. That is not an ambiguous case. There's going to be guaranteed to be one triangle there. Okay, and so we'll kind of breeze through some of these here. So, for example, the no solution case, that was that warm-up question that we had. That's why I kind of gave that to you here, so we can kind of breeze through it somewhat, right? It's the easiest situation where we have our triangle here, ABC, and we have 85 degrees here, we have the 25 here, we have the 15 here, and then as Robert had to set us up here, sine 85 over 15 had to equal sine of B over 25. We cross multiplied. I'm doing this wrong. Here we go. Okay, we got sine of B is 25 sine 85 over 15, and so we took sine inverse here of that quantity. And we got an error. And again, the reason for that is because this quantity here ends up being something like 1.660. I'm going to put a little squiggly equals. Okay. Anytime you see a squiggly equals, that means it's approximate, right? Not exact. So sine of B, right, it can never be equal to 1.660. There is no angle B that when you take the sine of it, you get 1.66 something, okay? Sine of an angle, the highest it's going to be is 1, right? The range of sine is just 1. Range of plain old sine is just 1, or negative 1 to 1. So it's just impossible, okay? Just impossible. So no triangle exists. No such triangle exists. Okay. All right. And so then we'll move on. We also saw in our warm-up today, we saw the one solution case. Okay. So just as an example here. And again, I'll just do the same triangle I did from the warm-up. Let's see, so we started with 42 degrees for angle A, 22 for side A, and then 12 for side B. Sorry, off the screen. set up here, right, we had to pick our angle on opposite side, so sine of 42 over 22. Ms. Danny to help us out with this one, right? And then we have to go for angle B because we have that opposite side 12 there. So sine of B over 12. Okay. When we cross multiply, we get sine of B is 12 sine of 42 over 22, and then we'll do sine inverse. Okay. Again, you guys have all this work, so that's why I'm just kind of breezing through it here. Okay. And let's see here, we get about like 21.406 degrees. Okay. And again, the idea here is that 12 sine of 42 over 22, in this case, right, this works. We're able to do it, right, unlike the previous one. If we look at, the decimal here, this decimal is approximately 0.365. Okay, sine of B is approximately 0.365, which does fall between -1 and 1, so there needs to be an angle, 21.406. Okay. So in other words, if I kind of work backwards here, let me show you this way too. So this angle, if I take the sine of it, I had better end up with that 0.365, right? That's how this sine inverse stuff works. If we do sine inverse of this quantity, which is about 0.365, so sine inverse of about 0.365, we end up with this angle. So if I take sine of this, I should go back to 0.365. So let's see here. Let's show you that. So sine of 21.406, and we do. We get about 0.365. Okay. So just going backwards there, right? You see it, 21.406, that angle. If we take the sine of it, we get back to that 0.365. But like I said, this is where this second possible triangle comes into play, because there's another angle. If you take the sine of the supplement, all right, so sine of 21.406 is this decimal, 0.364974283, right? But if I do the supplement, so 180 minus 21.406, that also is equal to the same exact decimal that we were shooting for up here, the 0.365. Okay? So that's why in this case we have to consider kind of the possibility for two triangles. Right? What is 180 minus 21.406? We saw that earlier, right? It was 158.594. So in addition to this angle, we have to do or 180 degrees minus the 21.406 degrees, which is 158. Okay. If both of these angles make sense in the triangle, we have two triangles. One triangle where angle B is 21.406, one triangle where angle B is 158.594, and we have to solve those two triangles kind of separately, right? Because it's kind of two different universes. It's like a multiverse thing. We got a one existence, like one universe where this is the right angle, and one universe where this is the right angle. So we have to solve the triangle separately and get different sides and angles and stuff like that. Okay? But since this one doesn't work, we throw it out, and we have the one solution case, and then we kind of proceed as normal. Okay? Because 158.594 plus the 42 is greater than 180 degrees, so the triangle is impossible. Or so the angle doesn't work. Okay. And I won't proceed with this again. You guys just saw that in the warm-up. You know what to do from there. Once we have that it's 21.406, we then just use another law of sines. Or sorry, we find the remaining missing angle here, which ends up being 116.594 degrees, and then we get that this is 29.400. Again, that was all from the warm-up there. Okay? Just using more law of sines. So then what does a two-solution case look like? Well, I've done no solution, I've done one solution, so let's look at a two-solution. Where we have two such triangles that exist. Okay? And so, again, I'm kind of letting the cat out of the bag here. You know it, right? Of course, I'm going to give you some homework problems, and in those homework problems, you won't know which case is which. You'll need to be able to, that's part of the challenge of it, is to figure out which one works and which one, or which ones, are 1, 2, or 0. Alright, so we'll start out with A equals 21, B equals 31, little b, sorry, so little a is, side A is 21, side B is 31, and then capital A, which stands for our angle A, is 30.5 degrees. Okay. So this has the added challenge of having to draw the triangle. So why don't you guys go ahead and take like 30 seconds and draw this triangle with the setup here. So go ahead and draw that setup there, and I'll do it too. So again, you can really draw your triangle however you want. You can label it, your vertex A, B, and C, capital A, B, and C, wherever you want there. Those are the angles. And then your sides, you're locked into your sides, right? If this is angle A, 20.5 degrees, then the opposite side has to be little a, the 21 there. Okay, question, James?
For the A on top, you wrote 30.5 degrees.
Sean, is that what you're going to say too?
Yeah.
I apologize. Okay, good. Thank you for that. It is, actually, it's supposed to be 20.5. I apologize. Sorry. Can we make that 20.5? Because I just want to make sure this works out correctly. So, I'm sorry, folks. It's supposed to be 20.5 there. It's probably my self getting distracted. So it's supposed to be 20.5. My apologies. Okay. So again, let's set this up, okay, to get to a place where we can actually solve. Okay. So the setup is just like any other law of sines problem. Let's see here. So Matt, how can we go about setting this up? How should we set this up? So what? Set up for the law of sines here. So sine of what angle over what side equals sine of what other angle over what side, kind of thing.
Sine of 0.5 over 21 equals sine of the other thing.
There you go. Good. Okay. So we cross multiply and solve here. We get sine of b equals 31 sine of 20.5 over 21, which as a decimal, I'll show you that approximately, but again, I'm going to do precisely here when I do the calculation. So it's approximately 0.517. Okay, is that value there? But again, when I solve for b here, I'm actually going to do sine inverse of this quantity. Okay. But the idea is, again, we're trying to find all the angles B that would work in this triangle and that result in this ratio, which is approximately 0.517. So all the angles B, all angle B's, okay, when you take the sine of them, result in this ratio, which is about 0.517. Okay. So we do that in our calculators. Second sine, 31 sine 20.5 over 21. And I get about 31.129. Okay. So when you take the sine of 31.129, it ends up being about 0.517 if I show you here. Just to make sure you see that. Okay. So if I take again sine 31.129, it is about 0.517. Right? Okay. It's pretty darn close. Actually, it's almost exactly the same. Okay, at least for the first couple decimal places there. But there's another angle, and here's where it comes up, that two situation case, right? There's one other angle. If I do 180 minus 31.129, I get 148.871, which when I take the sine of that, take the sine of 148, okay, it also is just about 0.517. And so we also need to consider that one. Okay. Does this second angle make sense in this triangle? Is it possible? With a 20.5, it is, right? 148 plus 20.5, that's less than 180. So we'll have some angles left over, some angle measure left over to then have an angle C as well. Okay? So here's the two cases. We're going to have case 1, where angle B is 31.129. And then we'll have case 2, where angle B is 148.871 degrees. Okay? In either case, what's going to be the next piece of the triangle that we solve for? It's got to be what? Angle C. It's got to be. So we're going to do 180 minus the 31.129 angle B minus the 20.5 angle A. Okay? So we get 128.371. Whoops. Okay, so there's angle C. There. Okay, for this angle B, right, it's going to be the same thing. We're going to solve for angle C, but now we're going to use the other angle B. So it's going to be minus 148.871 minus the 20.5. So you get like 10.629 degrees for this angle C. Okay. Again, it makes sense. Angle B is different for each triangle, then the angle C's are going to have to be different as well, right? And then what's the last thing we're going to solve for? We have angle B, we have angle C. What's the last piece we need? Side C, exactly right. And so we'll do, sine of the angle C, 128.371 over little c equals, and then I'll do sine of, I'll use my A again, 20.5 over 21. And then here it's going to be sine of 10.629 over little c equals sine of 20.5 over 21. And again, we cross multiply and solve. This case, C will be 21 sine of 128.371 over sine of 20.5. And this one here will be C equals 21 sine of 10.629 over a sine of 20.5. And that results in C being approximately 47.013 here, and side C is approximately, squiggly equals, approximately 11.060 here. Okay? And so that's a situation where you run into two possible solutions. Again, just because you're using law of sines doesn't mean you're going to have this ambiguous case. Okay? If you have a situation where you have angle side angle, then you use the law of sines, so you don't have to worry about the ambiguous case. Angle side angle guarantees a unique triangle, one unique triangle. Okay? Side side angle, though, that's where you do need to consider the ambiguous case, where it could be 0 triangles, which is easy. The calculator will just give you an error, which you'll know then you're done. Then you have the 1 or the 2. That's where it's tricky. You have to account for that first angle you solve for. You have to subtract from 180 or not. Okay? So that's the idea there. Questions on any of that? All right. So I'm going to take like 5 minutes and just kind of introduce the idea of law of cosines. We'll do one law of cosines problem. We're going to do more law of cosines tomorrow, but I'm going to introduce one today. Okay. And then we'll get you guys started on your assignment here. Okay, hope we get you guys started. All right, so law of cosines. Okay. So law of cosines, this works for side-side-side triangles and side-angle-side triangles. Okay? So law of sines, we use angle side angle, angle side technically as well, and then angle side or side angle. So then law of cosines takes care of the other two trig congruencies, side and side angle side. Okay? And of course hypotenuse leg, you don't need to worry about it because it's a right triangle, so you can just use normal trigonometry for that. Remember all that. All right, here's law of cosines. Here we go. C squared equals a squared plus b squared. It's like the Pythagorean theorem. But of course, we don't have a right triangle, so we need to have a little bit of a correction. So it's c squared equals a squared plus b squared minus 2ab cosine c. That's law of cosine. C squared equals a squared plus b squared minus 2ab cosine c. Okay? And then there's, of course, different formulations depending on what sides that you're solving for, but it really doesn't matter too much. So anyway, I'll show them to you. So we could also rearrange these. If we have b squared here, then the other two sides will be the a squared plus c squared. Right? So if we just kind of move these around, if it's equal to b squared, that's a squared plus c squared minus 2ac cosine, and then it's angle b. Okay, so you see the letters just change around. If you have your b squared here, then it's a squared c squared here, it's ac here, and that's angle b here. Here it's c squared, so it's a squared b squared, ab, and then angle c. And so then for the last one with a squared, it would be b squared plus c squared minus 2bc cosine, and then angle a. Okay? And so I'll actually show you one example here of this. Okay? And we're just going to solve for a. We're not going to solve for the entire triangle here. We're just going to solve for a. Little a. Just going to draw a triangle here. Okay. So, which form of the law of cosines should we use here? Can we use any of them? Can we use any of them? Or sorry, would any of them be helpful, I guess, maybe. So, Devin, what do you say? Okay, so it's a side angle side. So we know we can use law of cosines here, right? We can see, for example, law of sines wouldn't work, right? Because here we have an angle, but no opposite side. Here we have a side, but no opposite angle, and no way to find that opposite angle, right? Because we only have one angle here. And here we have, again, a side and no opposite angle. So, again, law of sines we know doesn't work. So it has to be law of cosines here. But we have three different versions of that law of cosines. So, James, what do you say?
We'd be using a squared.
We want to use the a squared equals, we want to use the third form of it here. How'd you determine that, James? Did you, any idea, or you just kind of just had a feeling?
Because we had sides B and D and angle A.
Aha, very good. Right, we have side C, which is 19, right, opposite angle C. We have side B, opposite angle B there, and we have A. So that's going to take care of BC, and A, and we're trying to solve for little a here. Let me just show you hypothetically, if we had chosen to use this first formula, what would have happened. All right, so we do know side C, it's 19. So you'd plug in the 19 squared. We then have A we don't know, so we'll say it's a squared. We then have B, which we do know, 46 squared, minus 2 times A, we don't know A, times B, we do know B is 46, and then cosine, excuse me, of angle C, which we don't know. So here again, we're using the incorrect version of the law of cosines. What's the problem with this setup that we've got right here? Why isn't it helpful? I mean, it's not wrong, but why isn't it helpful here? What's the problem with this? Trying to solve this for A. Yeah, Deb? Too many variables, right. We got A and angle C here. two unknowns in a single equation. We can't solve a single equation with two unknowns. Okay? So we don't want to use that. We want to use the one that James said. The a squared equals b squared plus c squared minus 2bc cosine a. Okay? So we plug things in now. A squared, we don't know a, so we'll just say it's a squared, equals, b is going to be 46, c is going to be 19, minus 2 times 46 times 19, cosine, and angle A we do know is 45. Could we simplify this one without a calculator? Do we need a calculator to do this problem? What's the cosine of 45? Root 2 over 2. You don't need a calculator for this. But we're going to use the calculator for it. Okay? We know the cosine of 45 degrees is root 2 over 2. It's the ratio, root 2 over 2, from our unit triangles. Okay? So, but we're going to use we're going to use our calculators here. Because I guess, yeah, we'll be taking the square root of a weird sum there too. So anyway. Alright, so 40, so when you type this in, please be careful. Alright? I get all sorts of weird answers. Follow, first of all, if you want to, you can just type this whole mess in. Okay, so you can do 46 squared plus 19 squared minus 2 times 46 times 19 cosine 45, just like that, and hit enter. Okay, that is a squared. Okay, and then we'll square root both sides, and so we get 35.228, we'll say. Guess I should have squiggly equals here too. And so there's the measure for side A, about 35.228. If you wanted to continue from here, how would we proceed? What would we do? What could we use? Yeah, it's law of sines. We can use law of sines now. We have an angle and opposite side pair. We can now just use law of sines and go from there. Okay? Do we need to worry about the ambiguous case for the law of sines? Do you need to worry about the ambiguous case? What do you say, Devin?
Yes.
Why do you say yes?
Because the highest value cosine can be is 1.
Okay, that's right.
Wait,
Highest value cosine can be
I don't
is 1.
know what I'm talking about.
Okay, I mean that's not wrong, okay, but I don't think that quite justifies what you were trying to say. So let me ask you this, okay, again, what would we start with? Side, angle, side. That's a triangle congruence, guaranteeing one unique triangle with that information, right? One unique triangle. So in this case, you don't have to worry about the ambiguous case either. So again, the only time you need to worry about the ambiguous case with the law of sines is when you have side, side, angle, or angle, side, side. Okay, and that's it. Alrighty, so there it is. There it is. Let me give you guys your assignment here so you can get started on that. Okay, your assignment is going to be 5 problems.
Yeah, but I'll just get it from unless you
Page
want
434, 13, 29, 31, and 52. And then page 441 and verse 13. Okay? I believe I chose the law of sine problems in such a way that you end up with one that has no triangle that exists, one that has one triangle that exists, and one that has 2 such triangles that exist. 52 is a word problem, but they already have it kind of set up for you. Okay, it deals with bearings. We'll look more at bearings tomorrow. And then 13 is a law of cosines problem because it's in that other section. Okay, we're going to do more law of cosines tomorrow, but I figure I'd get this to you right now. Okay? So please take the opportunity now to get started on this and working, okay? Please take the opportunity to get started on this. You have time, make use of it. Don't procrastinate. Please, don't procrastinate. Yes.
I was looking at my grades.
Yes.
And yeah, I know it's pretty bad. But
Well.
yeah, I was gonna talk about that instead. But there's this one I wanted to see in particular. It was like 4 out of 100. And I was like,
Oh yes, I need to fix that.
I was like,
What's that for?
oh, this is I think it's classwork.
Okay, I need to fix that. Thank
Yeah,
you.
you'll see it.
Sorry.
No
I
problem.
think yes.
I was like, huh. I mean, I'm bad, but I'm not that bad.
I know, right? That's pretty awful. I'll fix that.